Now I'm going to share the screen. So this is your lesson 1. So it's just you can say a review of your grade 11 functions. So here we will just have a little bit review about relation and functions. Then we will represent relation and functions in set notation, mapping diagram, and graphs. Then I will introduce the vertical line test. I think you already know the vertical line test, right?
Yeah.
So what is a domain and range? So we will introduce the function notation as well, and composite functions.
Okay.
So first topic is a relation and functions. So can you tell me what the difference between the relation and function?
A relation is a set ordered pairs, and then a function is a set of ordered pairs in which every x value there is only one y value.
Yeah, so whatever you told me, that is actually a definition of a function. That ordered pair, or whatever things we take in ordered pair or in connection, every x value has single value of y. That is a definition of function. If you will talk about the relation, in relation it is not necessary to have every x value should must have a single value of y. Okay, so it is not necessary for the relation thing, but for the function thing, it is very important that every x value should have a single or unique y value. Okay, so this is the main difference between the relation. Relation means any connection, whatever, connect, there must be some connection. That can be anything. If we will talk about a person and their liked games, then you can say, if we will take, let's say I'm going to name some people A B C D. So A B C D, I'm going to write it here. So let's say I have people A B, you can see.
Yeah.
Okay, so these are some people, let's say. So let's say if A likes football, B likes hockey, C likes basketball, D likes cricket, and E likes, let's say, tennis. Okay, so these are, I will make the ordered pairs. Okay, one more thing. This is each and every person likes single and unique game.
Yeah.
No game is repeating, right?
Yeah.
So I can say, yes, this is an example of function, right or not?
Yeah.
Yeah. But if I will say, let's A like football, B like hockey, C also likes football, and D likes, you can say, tennis, and E likes cricket. So is this an example of a function or not?
I think it's an example of a relation.
This is a relation or function?
Function, sorry.
What is the definition of function actually? Can you tell me again?
Function is a relation of a set of ordered pairs in which every x value there's only one y value.
Yeah, means every x value has only one y value. That means like in x, these are our x and these are our y's, right?
Yeah.
So here there can be same x values which can have unique y values. It can be. So yes, it is a function.
Okay.
Okay, but there should not be like that. If I will write like that, one example, look, A, B, C, D, E. Let's say A likes football, B likes hockey, and A also likes cricket. Okay.
Yeah.
And C likes tennis, D likes cricket, and E likes soccer, let's say. So this is not an example of function, because one input from the x values have two outputs, right?
Oh, okay. Yeah. Okay.
So this is a relation, yes, but it is not a function.
Okay.
So this is the difference between relation and function. Relation, any connection, anything, yes, it will be a relation, but for to be a function, there should be unique and single output.
So because it had both, like it had two values for y, that's why it's not a function.
Yes, that's why it's not a function.
Okay.
Okay. So single value of x cannot have two values of y.
Okay.
Got it?
Yeah.
So next thing is, this was relation and function. So I already explained you the definition. This whole material is in your Google Classroom. If you want to review it in detail, you can read from there. Okay. So this is the first thing which we did, that was ordered pairs, right?
Okay. Yeah.
So like A and tan is like, if I will write in this way, these are called ordered pairs. And another representation of function, this is called mapping diagrams.
Okay.
Okay, mapping diagrams. Mapping diagrams we represent in like circles. This thing is our input, or you can say X values, and in the, like here is our output, you can say Y values.
Okay.
Right? So tell me here, this mapping diagram is a function or not?
It's not a function.
No, because this 9 is going to have is having two outputs, right? So this is not a function, right? So this is an example. We can see like by drawing a mapping diagram, if a table, okay, and this was a second representation mapping diagram. This was the first representation ordered pairs. What is the third represent? A table. We can represent any function as in a table form, right? If you write here X values, here Y values, this is also one kind of representation like of a function, right?
Yeah.
Okay, and the next thing is, okay, so tell me, this check your understanding A. Does the following pair of ordered pair represent a function?
Yeah, I think it does.
Look
Yeah,
properly.
it does.
Yes?
Yeah.
Okay, so look, this in these ordered pairs, this 2 is having output -4, negative 2 is having output -4, and again -2 is having output 1.
Oh.
Right?
Yeah.
So no.
Oh, okay. Yeah, I didn't. Okay.
Okay.
Yeah.
And next thing is, okay, so again, we can represent these kind of like ordered pairs in form of graph also. Another way of representing the function is a graph form.
Okay.
Right? So this 9, 4, 1, 0, like these are our inputs, and the second numbers Y values, those are our outputs. So look, here we have plot the graph. First these dots and then these dots for A, and this is for B graph, right?
Yeah.
So we can represent in graphical form also. Okay, now next thing is, what is a vertical line test? So can you tell me what is a vertical line test?
Like a vertical line that's drawn that passes through more than one point on a relation.
Sorry, come again.
It's like like a line that's drawn on the graph that passes through 2 or more points on a relation.
Yes. So if it will pass only one point in a relation, then
it's not. It is a function.
Then it will be a function. Yes. If that vertical line, like for a single value of X, let's say if I'm going to draw a graph here, a rough graph, let's say this is my graph. Okay.
Yeah.
So I will draw a vertical line like that. For one single value of X, I am having one single value of Y here, right?
Yeah.
So I will say, yes, this is a function. But let's say if I'm going to have this kind of graph, like this kind of graph, and I will draw the vertical line test for single value of X, I am having these two values of Y here, right?
Yeah.
So I will say, no, this is not a function.
Okay, yeah.
Right? So this is called the vertical line test. Got it?
Yeah.
Okay, so we will move down again. So look, they have plotted the ordered pairs which we were given in like previous question, this one, right?
Yeah.
So they have drawn the vertical line test, and this vertical line test for this single value of X, it is giving us two outputs. You can see.
Yeah.
So that means this relation is not a function.
Yeah.
Okay. So in this B portion, when we plot this B part, B ordered pairs, so each and every, like whatever, no matter where we draw the vertical line here, here, for each and every single value of X, we are having single value of Y, right?
Yeah.
So yes, this is a function.
Okay.
And tell me, is this a function?
Yeah. Yeah.
Yes or no?
No, it's not a function.
Yes, because if we will draw a vertical line test, look, it is giving us again two outputs. No matter where you will draw the vertical line test, no matter where you will, how many vertical lines you will draw on the function, it is always, it is giving us two outputs, right?
Yeah.
So it is not a function.
Okay.
Okay.
Yeah.
So next is, okay. Next, the second is domain and range. Can you tell me what is domain and what is range?
Domain is, I think, like,
if we will talk about the mapping diagram or anything, whatever function is given us, let's say this ordered pair or whatever function fx is given to us, it is like a machine, right?
yeah.
And in this machine, we put some input values, that means x values.
Yeah.
Right? And those x values, this function processes, that means if it is some kind of linear relation or quadratic relation or any relation, it calculates, it solves it and give us one y value, right?
Yeah.
And that y value, this x value is called input.
Yeah.
And these y values are called output, right?
Yeah.
These inputs are a kind of domain. Okay.
Okay.
The difference, you can say that input and domain are a kind of same thing, but if you will say that it both are same, that can be correct, but that cannot be correct at the same time. Why?
Okay.
Because input means no matter what value, we can put everything in fx, right?
Yeah.
But domain means we can put only those values from the input on which that function is defined.
Okay.
That means, let's say, I'm going to give you one example. Let's say I'm going to take fx as 1 upon x. Okay.
Yeah.
So what x values you can plug in this x? 1, 2, 3, 4, 5, 6, 7, 8, -1, -2, -3, -1000, -100, +100, +10 million, like any number you can put.
Yeah.
These all are domain inputs as well as domain, right?
Yeah.
But if you will put 0 in here, then
0, then nothing would really change.
Yeah, so if you will put 0 in here, it will become 1 upon 0, and 1 upon 0 is not defined, because 1 over 0, we don't have, like in mathematics, this kind of number.
Yeah.
Right?
Yeah.
So if we will put x, like 0 in place of x in this function will not be defined. So we cannot take this 0. So we in this function, we cannot take x is equal to 0, right?
Yeah.
So that means from all the inputs, whatever we have, from all the inputs, we will leave 0.
Okay.
Right? So
Yeah.
this means, this is the difference between domain and input. Input means everything, and domain means those selected values at which our function is always defined.
Okay.
Got it?
Yeah.
Sure?
Yeah.
So don't get confused between input and domain. Input is like, domain is kind of input, but not the same thing.
Okay.
Input, we can plug everything, but domain, we have to take those values from the input where our function is always defined. We cannot take those values where our function is not defined.
Yeah. Okay.
Okay. Got it?
Yeah.
So same thing. What is the range? Range is our output.
Okay.
That is the same thing. Okay, that whatever domain we will put in x, and after putting that domain values, whatever output we will get, that is our range.
Okay.
Got it?
Yeah.
Sure?
Yeah, like it's once I like do the homework and like worksheets, I think I'll get it even more.
Okay. So next, this is domain and range, everything which I explained to you. This is whole everything, like the explanation. You can read it after. Okay. So this is example number 1. The line is given. This graph is given, and from this graph, tell me the state, domain, and range of the following, whether, and also tell whether this is relation, this relation is a function or not? Tell me. First of all, tell me what is a domain and what is a range.
Oh, well, the domain is everything that, like all the values that define the function.
Yes. So in this, you can see that this line is extending, right?
Yeah.
So this is going, this will go over like here, go
Yeah.
extending. It is also extending. So that means these, all the values that this line is covering, all the values of x-axis.
Okay.
No matter decimal, like everything, right? So
Yeah.
we can write domain is a real number. Sorry, my bad. Domain is x belongs to real numbers. In real numbers, everything is always included. Integers, whole numbers, decimal
Okay.
numbers, like everything comes.
Okay.
Whole number line comes in real numbers.
Okay.
Okay. So because this whole, everything is coming in the domain, so I will write this. What about range?
Your range is like the number range between how, like, it's how from where to where it's extending, I think.
Yeah, again, so from negative infinity to infinity, because again it is extending.
Yeah.
Like, look, this line will go extend. That means this whole line will cover up, this whole line will cover up, it will go down, right?
Yeah.
So again, that means x belongs to, again, real numbers, the range is equal to, or you can write from negative infinity to positive infinity and negative infinity to positive infinity, like it's your wish, what like how you want to write.
Okay.
Okay. And what about, is this relation a function?
Yeah, no, it's, oh wait. Yes, I mean,
Yes.
yeah.
Look, draw the vertical line. No
Yeah.
matter where you are drawing this vertical line, it is for each value of x, it is giving single value of y.
Yeah.
So yes, it is a function.
Okay.
Got it?
Yeah.
Sure?
Yeah.
Okay, so let's move further. This is the explanation. You can read it afterwards. And you know, like this is the sign of belongs, or you can say y is an element of our real numbers.
Yeah.
Okay.
Yeah.
Okay, so B part. Is this a function? And tell me domain and range.
Yeah, it is a function.
Okay, it is a function. Yes, good. And what about domain and range?
Domain. For domain, I think it's set of all real numbers.
Yes, for domain, because this is again extending, right?
Yeah.
So if this is extending, so it will go up, like all the way up, like this. The whole line is going to cover from left as well as from right.
Yeah.
So x will belong to all real numbers, or you can say from minus infinity to infinity, as you wish, whatever you want to write. What about range?
Range, I think it's positive, the same thing, positive infinity, negative infinity.
You can see this parabola, it is starting from here. It is not going down, right?
Oh, yeah, it's not.
Yes, so it is starting from here and it's going up. So that means starting from 0 and going up. So range will, y is greater than and equal to 0.
Okay.
Or if you want to write in interval form, you will write 0 to infinity, right?
Oh, yeah.
And 0 is included, right?
Yeah.
Whenever 0 is included, we put this capital bracket, and infinity, we never include infinity. I will put open bracket, small bracket.
Okay.
Okay. This open bracket, close bracket, this concept is going to come in the next lesson. So I will explain that also.
Okay.
So you got it?
Yeah.
Sure. Let's move further. So this explanation is here. You can read afterwards if you want. So this question, this C part again. What is the domain here? Because, okay, tell me first, is this a function?
Yes, it's a function.
Yes, it is a function. What about domain?
Domain, I think it's, wait, this is kind of tricky.
You can see these dots.
Yeah.
That means at these places, this function is stopped. It is not extending.
Okay.
So if it is not extending, so that means we will start from here, -6, and it is ending at here. That means here is -3, right?
Yeah.
So domain is going to be starting from -3 to -6. And I will put capital bracket because -3 is also included, negative and -6 is also included.
Okay.
This is my domain, right?
Yeah.
And what about range?
Your range would be wait, wouldn't it be the same thing?
No, range, like for domain, we look at the x-axis, and
Okay.
for range, we look at the y-axis. Now, for like according to the y-axis, this function is starting at this point, right?
Yeah.
And it is ending at this point, right?
Yeah.
So that means from 1 to -9.
Yeah.
So
Okay.
this is my range.
Okay.
So domain, like this function is here on x-axis and here. Like for domain, I will see x-axis, the starting and ending of the function, and for range, I will see y-axis, the starting and ending of the function.
Okay.
Got it? So
Yeah.
it will be from 1 to -9. So negative number always comes first. So sorry, it will write from -6 to -3 because small number we write at first. So it will be -9 to +1. This is how you will write.
Okay.
Got it?
Yeah.
Okay, let's see its answer if we are, yeah, look.
Okay.
Okay,
Yeah.
so they have written 6.1 or approximately, it's because it was not written exactly, so 6.1 or -6 approximately, it's correct.
Okay.
Okay.
Yeah.
So again, this, is it a function or not?
This is not a function.
Okay, and what about domain and range?
Domain would be, wait, let me think. Would it be from 0?
Look, this from according to the x-axis, this function is starting at this point, right?
Yeah.
And ending at this point, right?
Yeah.
So domain will be
it would be from 4 to
-5 to 4.
Yeah. Okay.
And capital bracket because -5 and 4 both are including.
Yeah.
And range is like what you were talking about from 0
okay.
to this, that was range. We see
Oh.
range on y-axis.
0, so it'd be 0 to 4?
Yes.
Okay.
Okay, so from 0 to 4, this is my range.
Okay.
Okay.
Yeah.
Okay, so check your understanding. So these are kind of same questions. Okay, in this question, what do you think? What is a domain?
Domain would be -4 to 6.
To 7.
7, yeah.
Yes. And what about range?
0 to 2.
No, it is starting from here.
Oh.
1.
Oh, yeah.
So 1 to
2.
this, and last point is at 9.
Oh, okay.
Okay, not 2. Like we will say, see the whole function
yeah.
where it is ending. So starting from 1, and this line is going all the way up from here at 0.9.
Okay.
Okay.
Yeah.
Okay, so that completes your second lesson also. So next,
we're doing 3 lessons every day.
We are doing like, this is a kind of review lessons, and we will do 3 lessons every day. And today I will give you 2 lessons from the review and 1 lesson from your book, the function, power function. Okay. So, and from tomorrow we will do like every 2, again, like 1 hour we will do 2 lessons of review, and then other 2 hours we will do 2 lessons from your book, power function. Okay. Because this review lessons are also included in your power function thing. Okay. Your syllabus. Okay. So function notation. You know what is a function notation?
I sort of forgot.
Okay, so function notation, you can read this whole explanation from your notes, but I will give you just overview. Function notation, like if let's say I have fx, and I will plug x is equal to 2, and I will get the value the value of f2 is equal to 4. Let's say this is an example. If I will plug 2, okay, let's say I'm going to give you one example. Let's say my function is fx is equal to x plus 2. Now in this x plus 2, if I will plug 2 in place of x, 2 plus 2, I will get 4, right?
Yeah.
That means after plugging this 2 in place of x, I got this 4.
Yeah.
So that means the value of function at x is equal to 2 is 4.
Okay, yeah.
So this is called function notation.
Okay.
Like this fx will be my y is equal to fx will be my function notation. And if I need to find this value of function at some value of x, I can find like that.
Okay.
And that thing is called, we can say like f at x or f of x.
Okay.
Okay, like
Yeah.
you can say x at domain, like whatever value of domain we will put in the function, and we are going to get the range values, right? So
Yeah.
that is that function where we put the values, that is the function notation. If we have the function notation, then it is possible to plug the values of x. If we don't have the function notation, if we don't have this function, we cannot plug the values, right?
Yeah.
So that is a function notation. Okay.
Okay.
So it is like they have given the function as fx is equal to x cube, and they are plugging these values in this function, and they are going to get these. Okay.
Okay.
Okay. So this is one example. Tell me how you will do. Your fx is given like this and gx is given this. They said evaluate f negative 6 and g negative 3. What you will do?
Oh, wouldn't you do an exponent?
Your fx is 2x plus 3, right?
Yeah.
You need to find f negative 6.
Oh, so wouldn't you just plug it in?
Yes. So f negative 6 means in place of x, now you have negative 6. That means 2 times negative 6 plus 3. That's it.
Oh.
Negative 12 plus 3. So that means negative 9 answer.
Okay.
So your value of function at x is equal to means f value of f at x is equal to negative 6 is negative 9.
Okay.
Got it?
Yeah.
So this is called the function notation. Okay.
Yeah.
Same as it is now, you have the function gx is equal to x square plus 4x, and you need to find g negative 3. What you will do?
Just plug it into the equation?
Yes. So g negative 3 is equal to negative 3 square plus 4 times negative 3. So 9 minus 12 is going to be negative 3, right?
Yeah.
So this is how you will do. Got it?
Yeah.
Okay, so these are the solutions. These are the same kind of exercise, so you can do it. Okay, one question, a different kind of question now there is. Look, example number 2. It said fx is given this and gx is given this same thing. For what value of x, fx is negative 8. Now this like answer is given to us. We need to find the x value, what we will plug to get negative 8. Okay.
Okay.
So fx is equal to negative 8. This is given, right?
Yeah.
Fx means whole thing is negative 8. Like
Okay.
after plugging whatever answer we usually find, that thing is given.
Okay.
We need to find what we will plug in. Okay.
Yeah.
So in place of fx, I will write fx. My fx is 2x plus 3, right?
Yeah.
Is equal to negative 8.
Yeah.
Now I will find x from here by isolating method, remember? So how we do? 2x plus 3, negative here, 3 to the left and negative 3 to the right, right?
Yeah.
And it is going to be this positive and negative will become 0, and 2x is equal to negative 11. And then 2x divided by 2 here and divided by 2 here, right?
Yeah.
So it is going to be x is equal to negative 11 by 2.
Okay.
This will be my value of x.
Yeah.
Got it?
Yeah.
Okay. So this is, look, right?
Yeah.
So now next C part, fx is given, gx is given. It said what value of x does fx and gx equal. So for what value of x? Fx and gx are same, equal. There is equality sign here. That means fx is 2x plus 3. It is equal to gx. That means x square plus 4x, right?
Yeah.
So we will solve it. I will take these both things to the right side. How? 2x plus 3 minus 2x to the left and minus 2x to the right. Right? So here these both become 0, so only 3 is left. X square plus 4x minus 2x will become plus 2x. Now 3 minus 3 to the left and minus 3 to the right. Here I will get 0 is equal to x square minus 2x minus 3. And I can flip this equation, right? X square minus 2x minus 3 is equal to 0. So now after solving it, this is a quadratic equation, right?
Yeah.
So you know how to solve the quadratic equation? You can try either by factorization or discriminant method, whatever you want.
Okay.
Or you will find the value of x. Okay?
Yeah.
So you have the solution here. After that, you can have a look. They have done the, sorry, this is 2, it should be square. Okay, I will make this is x square. Don't get confused. There's a little bit mistake.
Okay.
So they use the factorization method. So they make 2 factors. And then after this equating to 0, they got these 2 x values.
Okay.
Okay. So these are some more examples of, okay, yeah. So one more thing. It is composite function. What is a composite function? Look, f of g of 5.
Okay.
Means function in function. You have to, before what you do? You plug a value in a function, right?
Yeah.
But here, first of all, you have to plug the value in a function. Then that function you have to plug in another function. Okay?
Okay.
So what you will do? F of g of 5. So you have gx, right?
Yeah.
So first of all, g5. G5 means you have gx is equal to x square plus 4x. So you will find g5. So g5 means 5 square plus 4 times 5, right?
Yeah.
So that means 25 plus 20, it will be 45, right?
Yeah.
So that means the value of g5 will become 45, right?
Yeah.
Now you have to find f of g5, right? Right, Aisha?
Yeah. Yeah.
So f of, in place of g5, you can write 45.
Yeah.
That means in f function, you will plug 45. So what is f function? 2x plus 3. That means 2 times 45 plus 3. 90 plus 3, 93. Understood or not?
Yeah.
Sure.
Yeah.
So this is kind of a composite function. That means plugging a function in another function in place of x. Okay.
Okay.
Got it?
Yeah.
Okay. So yeah, these are some more examples you can see in your notes. And yeah, this is a detailed example of composite functions again. So again, fx is this, gx is this. So f now in journal, look, you have to find f of gx. So f of gx, how you will find? Look, you need to find f of gx. So that means this is your gx and this is your fx. So in fx, in place of x, you have to plug this thing, right?
Yeah.
So that means 2 in place of x, you will write x square plus 4x plus 3. This is f of gx, right?
Yeah.
So you can solve it. 2x square plus 8x plus 3. That's it. Look, this thing we got.
Okay.
Okay, this was f of gx. But if we will find g of fx means now it's a reciprocal. Before in this question, we plug g function into f function, right?
Yeah.
But now we will plug f function into g function. Okay, look, what is the g function? It's x square plus 4x. Now, because I am going to find g of fx, so that means this fx I will plug in g. So this is my fx, I'm going to plug this in g. So that means in place of x, I will write fx, 2x plus 3, and up here, this is whole square, it will become here whole square, plus 4. Again, in this x, I will plug 2x plus 3. Understood or not?
Yeah.
That means that this was my fx, right?
Yeah.
I plug this fx in place of x in the g function.
Yeah.
Got it or not?
Yeah.
Sure?
Yeah.
You know, you can solve it. You know what is the formula of a plus b whole square? A plus b whole square is a square plus 2ab plus b square. Okay?
Yeah.
So 2x whole square plus 2 times 2x plus times 3 plus 3 whole square plus this you can multiply inside 8x plus 12. So answer you will get, you will open this whole square, 4x square plus 2 times 2 is 4, 4 times 3 is 12x plus 9 plus 8x plus 12. So that means 4x square plus like terms 20x, 12 and 9 is 21. So this will be your total answer. If you want to have a screenshot, you can have it, the solution of this. Otherwise, I'm going to share you the link of this video. You can see that video also.
Okay.
Okay.
Yeah.
So you want to have a screenshot of this?
Yeah, I just took a photo.
Okay. So I will erase this.
Yeah, you can erase it.
Okay. So that's it. It completes your, this is one understanding. You can check after in your notes. Okay.
Okay.
So it completes your first lesson.
Okay.
Okay. And the second lesson, I will post the link of the video.